Welcome back to Mass Production Marvels. Today, we unlock the epic scale of the industry that builds our world. The journey begins here, in a monumental limestone quarry. We are standing in the world's Grand Canyon of construction. Here, explosive forces shatter the mountainside, and gargantuan excavators harvest the essential raw material. Monstrous mining dump trucks, capable of carrying 400 tons, dominate this engineered landscape. Every single tire on this machine is an engineering marvel, standing over 4 meters tall. The truck pulls up to the primary crusher, a massive building designed to destroy rock on a monumental scale. Up to 2,000 tons per hour of limestone boulders crash down into the gaping maw of the gyratory crusher. Internal view. Inside, massive steel mantles wobble violently, pulverizing car-sized rocks into hand-sized stones in seconds. Below, the crushed stone stream falls onto a reinforced conveyor belt, beginning its journey to the factory. A kilometers-long overland conveyor belt transports the rock, acting as the industrial veins of this massive complex.
This soft, sticky clay
At the factory, the limestone is piled into colossal conical stockpiles, creating a man-made mountain of material. Simultaneously, a separate quarry provides the second essential ingredient, clay, adding silica and alumina to the recipe. The clay is transported, ensuring a continuous supply for this 24/7 manufacturing marathon. In the monumental storage hall, a bridge reclaimer with a 60-meter span systematically blends the limestone from the stockpile. Precise weigh feeders then measure the limestone, clay, and iron ore with surgical precision, creating the perfect chemical mix. Welcome to the raw mill building, a massive steel structure vibrating with the force of industrial pulverization. A vertical roller mill uses two 50-ton steel rollers pressing down on a rotating grinding table. CGI view. The raw materials are crushed by the rollers, while a powerful hot air stream lifts the fine powder instantly. At the top, a dynamic separator spins at high speed, ensuring only the finest powder raw meal can pass. This raw meal powder is then pneumatically transported to the top of the giant blending silo. CGI view. Inside the blending silo, compressed air blasts from below, fluidizing the powder and mixing it like a turbulent liquid. This crucial step ensures the material is perfectly homogenized before the chemical miracle of fire. In the central control room, operators monitor X-ray diffraction analysis in real time, checking every parameter. Lime saturation and silica ratios are controlled within precise tolerance bands. There is no room for error. A massive kiln feed pump then transports the perfect raw meal to the pinnacle of the preheater tower. Standing as tall as a skyscraper, the preheater tower is an engineered marvel of heat exchange. The raw meal is introduced, beginning a dizzying 100-meter descent through the cyclone tower. CGI view, illustrating how the material swirls downward while 1,000 degrees Celsius kiln gases swirl upward, exchanging heat instantly. These cyclone towers are engineering feats, made of refractory bricks to withstand the thermal and gas forces. High-temp camera. Glowing red raw meal is heated to over 800 degrees Celsius by the time it reaches stage 3. Next is the pre-calciner, a massive vessel where 60% of the fuel is burned to decompose the material. Pulverized coal or alternative fuels are injected at high velocity, creating an incredible inferno. CGI animation, illustrating the chemical reaction where limestone releases CO2, a process called calcination. A stream of white-hot quicklime now cascades directly into the rotary kiln, the heart of the factory. Behold the rotary kiln, the longest rotating machine on Earth. A 100-meter steel cylinder turning slowly on giant rollers. The massive riding rings, or tires, support thousands of tons, a testament to monumental mechanical engineering. The drive system and its gears must provide enormous torque to turn this titanic load continuously.
Phase 4.
Tracking along its length,
the
you
Inferno.
can feel the heat haze shimmering above the massive steel shell. A hydraulic thrust roller precisely manages the kiln's axial position, a subtle control of massive force. Cooling fans blast air onto the exterior shell, critical to managing the thousands of degrees internal temperature. Firing hood view. We are approaching the burning zone, where the real chemical magic happens. This is the 15-meter-long multi-channel burner, injecting fuel at subsonic speeds. CGI view, a visualization of the 1,450 degrees Celsius inferno, a flame as hot as liquid magma enveloping the material. High-temp camera, Inside the kiln, the quicklime fuses with other minerals, transforming into molten nodules. CGI animation. Sintering occurs. At 1,450 degrees Celsius, a complex mineral structure is born. C3S and C2S, the essence of cement. Kiln exterior. Sophisticated shell scanners provide a real-time thermal map to detect any refractory brick failure. Control room. The burner. The most experienced operator intensely monitors the raw material flow inside the fire. This live camera feed is the only way to see what's happening inside the fiercest industrial process on Earth. From the kiln, white-hot molten nodules cascade directly into the great cooler. Look at the colors. They change from glowing white to glowing red to gray, like cooling volcanic rock. The Great Cooler is a complex machine with movable steel plates that transport the clinker bed. Massive hydraulic rams push the grate plates back and forth, moving the material towards the crusher. Powerful fans below fluidize the clinker bed, maximizing heat transfer and cooling it rapidly. This captured heat is not wasted. 1,000 degrees Celsius secondary air is sent back to the kiln burner to maximize fuel efficiency. At the cooler exit, a massive clinker breaker, a roller crusher, breaks any large clinker blocks. A massive aerial shot of the 100,000-ton clinker storage hall. It is a city of clinker. Inside, a giant tripper conveyor or crane distributes the cooled gray clinker nodules. Underneath the hall, vibrating feeders drop clinker onto the final mill conveyor. Next is clinker storage and finish grinding. This building houses the massive finishing mills. Gypsum, a white mineral, is added to the clinker stream. This is the secret to controlling cement's setting time. We are now entering the finished grinding building, which vibrates with industrial power. Welcome to the ball mill, a gargantuan horizontal cylinder, 15 meters long, rotating at high speed. A massive dual pinion drive system and a girth gear provide the power to rotate this titanic mill. CGI view. Thousands of hardened steel balls cascade inside, pulverizing the clinker into a microscopic powder. From the mill, the finely ground cement is pneumatically lifted into the dynamic separator. This dynamic separator spins at high speed, ensuring only cement of the exact fineness can pass. The finished cement powder looks gray and flows almost like a liquid. This is Blaine quality control. Finished. Pneumatic systems and air slides transport the finished product to the monumental storage silos. Standing tall against the skyline are the massive cement storage silos, each 60 meters tall. Air fluidizes the cement, allowing it to flow like a liquid to the extraction points. All systems integrated. The main control room manages every single process, from quarry to silo. The quality control chemist uses a robot-operated X-ray fluorescence machine for perfect chemical consistency. This automated physical testing machine crushes cement cubes to determine their 28-day compressive strength. We now enter the packing plant, a building vibrating with the activity of bagging and bulk loading. An 8-spout dynamic rotary packer spins and fills paper bags with 50 kilograms of cement in seconds. A bag applicator robot places a new paper bag onto the spout with surgical precision. Cement powder blasts into the bag, which is instantly weighed and sealed before leaving the packer. Conveyor belts transport the filled 50-kilogram bags at high speed toward the automated palletizer. This complex robotic palletizer stacks bags in a perfect, stable pattern, ensuring safe transport. The robotic stretch hooder places a waterproof plastic hood over the entire finished pallet. A fleet of forklifts moves finished pallets to the warehouse, which can hold hundreds of thousands of bags. This is logistics on a monumental scale. Hundreds of trucks leave the factory gate every single day. Beneath a silo, a telescoping spout lowers onto a waiting bulk cement tanker truck. Cement flows at 300 tons per hour, filling the tanker in just a few minutes. A dynamic drone shot of the fleet of bulk tankers and trucks leaving the factory gate, carrying the world's foundation. The massive factory also uses rail transport, loading specialized cement wagons simultaneously, and even water transport, with barges receiving direct bulk loading from the factory conveyors. The cement trucks arrive at a massive construction site, where the product begins its new life. Look at the foundation. This concrete pump is pouring the base of a skyscraper, using mass production marble cement. The cement factory, a massive engineered complex where science, scale, and fire come together to build our world.
stone.